Hey folks, first off, wanted to start into today's lesson by recapping what we've been doing the last couple of days. As you know, we had started to look at this unit on circles, and there were two relationships that we have seen so far. So the first case that we had here was the case of the central angle. Here we go, central angle. Now, a central angle is an angle that is at the center of our circle. So it's well named central angle. And what we learned was that the central angle is the same measure as its arc. So the angle is 80 degrees, the arc is 80 degrees. Now contrast that to our second one that we had, which was our inscribed angle. Inscribed is simply an angle that is on the side of the circle right there. So the vertex of our angle is inscribed on the side of the circle. Now, the inscribed angle has a relationship with its arc as well. The inscribed angle is half of the arc, or the arc is double the inscribed, both meaning the same thing. So either 80 doubled gets me the arc of 160, or the arc 160 cut in half is the inscribed. So those have been the two that we've learned about so far. Today we're going to learn about another relationship or two here, but this time we're going to talk about angles other than just angles that are either inscribed or in the center of the circle. The first one that we're going to talk about is an angle outside of the circle. An angle outside of the circle. So an angle outside the circle. For instance, we've got this one right here. That one is, as it says there, 50 degrees. And we've got two arcs that it creates. Look at these two arcs here. This one here is 80. And then this one here is 180. Now, there is a relationship between 80, 180, and that 50 there. And there is a connection that I can use those two to get. All right, another example. The angle is 80 degrees. This part of the arc is 100, and this part of the arc is 260. Again, there is a connection between the 100 and the 260 that I could use those two numbers together to get me the 80. And one last time, a 50-degree angle. And the two arcs in this problem are 50 and 150. And again, there is a connection that I can use, 50 and 150, to get me that 50-degree arc. So I want you to look at each of these three cases on your notes there in front of you. Hopefully we've got those already passed out there. On those notes there in front of you, and the same that I have on the board, can you find a way to use 180 and 80 in the first problem? 180 and 80, use those two, that'll get you 50. Or a way to use in the second problem, 260 and 100, and use those two to get you to 80. Or in the third example, a way that 150 and 50 will get you to 50. So first, I'm going to give you a minute of silence here while you think about that connection. If you come up with the solution there, see if you can share it with the person sitting next to you. We'll give you guys the next minute to think about that. So there is a minute on the clock. You should actually be using this time to think about the problem, not just goofing around. And there we go. So stop that. All right, so this connection here, hopefully you caught it and you were able to share it with somebody sitting next to you. But the connection we have here is basically, if we take those two numbers, so in the first problem, 180 and 80, if you subtract those numbers from each other, you get 100. Cutting 100 in half, you get 50. Or in the second example, 260 minus 100 is 160. 160 cut in half is 80. Or the third example, 150 minus 50 is 100. 100 cut in half is 50. So the first relationship we have here is basically this. And you might want to take this down on your notes here. Major arc, so the big arc, the major arc, minus the minor arc, that's the small one, and then divide that by 2. And that will get you the angle. Major arc minus the minor arc, so big arc minus small arc, divided by 2 will get you the angle here. So in the first problem, 180 minus 80 is 100. That's the major minus the minor. Divided by 80. Or sorry, divided by 2. Sorry, 180 minus 80 is 100. 100 divided by 2 is 50. On the second problem, 260 minus 100 is 160. 160 cut in half is 80. So we've got this relationship for angles that are outside of the circle. So I'm going to go ahead and move down our notes just a little bit here. We will look at a couple of these examples. Obviously, there are a lot of examples there on your page. We might not get to every single one, but we're going to start to find this connection to be able to solve for that angle. So in my first example, I've got the major arc, the big arc, I should say, 178, minus the small arc of 76. And I'll divide that by 2. So 178 minus 76 is 102. 102 cut in half is 51. Therefore, my angle is 51 degrees. Try out that second one real quick. It should only take you 30 seconds or so. Now, Ryland, as I do this, 230 minus 130, take the major arc minus the minor arc. That's going to give me 100, and 100 cut in half will give me 50 degrees for my angle there. I'll tell you what, try out the 2 below it there, right there. Try those 2 out, see where that takes you. I'll put them up on the screen as you go through them, but you should be able to work those 2. So Ozzy, on that first one, I have 86 minus 34. That's the major arc minus the minor arc. Subtracting and then dividing by 2. So I've got 86 minus 34, and that's going to give me 52. And then 52 cut in half, oops, wrong button, is going to give me 26. And on that second one, 156 is my large minus my small of 60, divided by 2 again. And that's going to give me 96 when I subtract, divided by 2 will give me 48. Now, I can use this exact same framework we've constructed to actually work in the other direction and find the missing arcs here. This is where the math gets a little bit more complicated. So be sure that you're sitting up there, you get your notes there, and we'll go through a couple of these examples. Morel, make sure you're awake there. So on this next one, my major arc, okay, is going to be X. And I'm going to subtract my minor arc from that, which will be 84. And then divide that by 2. Now, the difference is here, I know what my angle is. So this is about as much algebra as we ever get. It's a two-step equation. But notice the formula here. This is the exact same one we established earlier. Major minus minor divided by 2 equals the angle. So my major, in this case, is x. My minor is 84 divided by 2. And that's going to equal my angle of 31 degrees. So then I just have to simplify it to get x by itself. Two very basic steps here. First step, I'll multiply both sides by 2 to clear the fraction. I'm left with x minus 84 equals 62. So Xander here, I've got x minus 84 equals 62. How do I get x by itself? We're going to add 84 to both sides. 62 plus 84, 146. And there is our value. So notice how I'm using the exact same process as the other problems here, but now I'm solving for a different element. So on a problem up here at the top, I was solving for my angle. 230 minus 130, major arc minus small arc, divided by 2 equals x. And then I just simplified and we got our value of 50 on that one. On the one here on the right, it's the exact same case. Major minus minor divided by 2 equals my angle of 31 degrees. But I actually have to do a little bit of solving there. And so that one can definitely prove to be a little bit more challenging. I might work a couple of these here at the bottom of my screen. Let me just scroll up for that. And then we will move on. I don't know how many more of these I need to do, but there will be a little recap at the end I want to get to. So on this problem here, major is 146, minus minor is x divided by 2 equals 33. Now, Flock, when I get to this point here, it's still the exact same process. I want to get x by itself. This is where our algebra skills start to become a little bit more important. We haven't really had to do much algebra, but I multiply both sides by 2. That'll cancel my fraction out. I'm left with 146 minus x equals 66. And here's where students will often make the mistake. They'll want to add 146 over, but that is a positive 146. I'm going to subtract 146 over minus 146. I'm left with negative x equals, that would be negative 80. But once you know that negative x equals negative 80, it's pretty easy to recognize that positive x equals positive 80. Now, some of you may be able to do part of this in your head because we know that 146, now that we know it's 80, we can see that 146 minus 80 is going to be 66, and half of 66 is 33, as we would expect it to be. A good way to check our work there as well. So we can get our results either way there. Now, I will just do one more problem here. I'll do this one on the bottom right. They want me to solve for x, but they don't give me any major or minor arc. However, this is a bit of a review. Let's tie it into what we know. The central angle is equal to the arc. So that arc there is 120. Now the circle has to add up to 360. Therefore, the rest of the circle has 240 degrees left for it. Now I've got my major and minor arc. But notice what I did here. I used the central angle of 120 degrees to figure out the arc, which is going to be the same. Central angle is always the same as the arc. And use the fact that a circle adds up to 360. So major arc, 240, minus minor arc, 120, divided by 2 will equal my x. 240 minus 120 is 120. 120 divided by 2 is 60. And therefore, x must be 60 in this case here. A bit of a different problem there, kind of a unique take on it. Now, you could complicate these problems on the other part of our notes there by really making the algebra messy. I will avoid doing that on an 80-level question on the quiz. 80-level questions would not have messy algebra. However, I can show you what that would look like just because we are here. So on this problem, got my major and minor arc, but the math is the same. Major arc, 3x minus 2, minus minor arc, x plus 6, divided by 2 equals my angle of 34 degrees. Now, you might look at this and feel a little overwhelmed because there is a lot going on there. And it's been a while since you've really used this algebra. However, the process is combining like terms. 3x minus x. 3x minus x, as we know, is 2x. And then, Emma, when I combine the negative 2 minus 6, that's a negative 8. So I'm left with this. Multiplying both sides by 2, I get 2x minus 8 equals 68. Adding 8, and I'm sorry, I am zooming through the algebra a little bit here because I'm not really going to hit you with a lot of problems like this. And then dividing by 2, I get 38 for x. That would be the one above. X equals 38. Now, that's more algebra focused than I really want to be, so I'm not going to really zoom in much more on these next two problems other than just to recognize that it is still the same process. Major arc minus smaller arc, major arc minus minor, divided by 2 equals our angle. All right, so what have we learned so far? Here are our three concepts that we've got at this point. First, we have the central angle. Central angle is always equal. So x would be 100 in this case. Second, we have inscribed. Inscribed. There we go. Inscribed is always half of its arc. So our arc is 100. The inscribed angle would be 50. And finally, we have, finally for today, I should say, there's one more case. We have angles outside the circle. Major minus minor divided by 2 equals our angle. So in this case, 260 minus 100 divided by 2 equals our angle. That's 160 divided by 2 is 80 for our angle. So we've got our three basic concepts here that we're dealing with. Now, for the rest of class here, let me jump over and show you what you guys are going to do. We've got a Desmos activity I'm going to have you guys looking at. You'll see that posted there in Classroom. There, it's our Desmos activity. The date is wrong. I will have that fixed probably by the time you see this video. So, on the Desmos activity, the first question will ask you, what one doesn't belong? I will tell you, there is no correct answer on this. You could make an argument for any one of these. I'm not worried about which one you pick. I'm worried about what you put here, why it doesn't belong. So your argument could be whatever you think. It's just you make the observation. Second, it's going to compare the inscribed angle, I, to the central angle. Now, I will point out these numbers are rounded, so it's not perfect. 40 and 79. If it didn't round it, it should be at 80. So 40 and 80. But you'll see that it's close enough to be able to make the connection. 45 and 90, you'll make the observation of the connection. Then you're going to use that same thing to record the measurements. So if angle A is 35, then C is, like I said, it's not perfect there. It's having a little trouble. There we go. C is 70. And you'll make each one, and you'll see the relationship on each one over here. You'll go through each of those. It's going to talk about how they relate, the inscribed and the central angle relate to each other. Talks about a 90-degree angle. I think that's relatively interesting. A really complicated looking diagram here. But as you start to move things around, you're going to notice that not a whole lot's changing. All right. Yeah, come on. Yeah, see? So I don't think once you start messing around with it, you're going to have any trouble making the observations. That's really what each of these is supposed to be, observing connections between the central angle and the inscribed angle. And in a little practice, with our angles outside the circle there. You guys are allowed to work together and talk to each other. Slide 10 says, which one of these statements is false? One of these three statements is false. Tough problem. You can talk to each other on them, help each other out. They want you here to create a false statement. The diagram is quite complicated. I'd like to see what we could come up with, though, and then you can make some of your own. All right, so that is what I'm asking of you guys to do for the rest of class. Hopefully you have those notes filled out. Those should be very helpful. And we can talk a bit more about this when we get back together on Tuesday. All right, good luck with it. Let me know if you have any questions.